we did vector, we did scalar, right? So certain terms we are going to do today. That term shall be, just right now, it shall be, one is a term called as relative velocity. Relative velocity. Second term would be force. Third term shall be pressure. Fourth term shall be power. Fifth term shall be, mark, work. Okay.
Yes.
Then we'll have kinetic energy. Then we'll have potential energy. Okay. So certain terms we need to do, in physics. These are the terms that you need to know before doing any term. So we have done also acceleration. Have we done acceleration, Mark?
Yes.
Okay. We have done distance up till now. We have done displacement. We have done speed. We have done velocity. And we have to do average velocity. So these are those important terms that you need to know. Okay. Now just see. So today, just let me recall a bit with you. One would be one would be the distance. What was distance? The length of the actual path. Second was displacement. Second was displacement. What was the displacement? For example, if I'm starting from A to B to B to C, so the length of the shortest path, this AC shall be my displacement from my initial to final position. Yes or no, Mark?
Yes.
Yes. Now understand. Now understand. So, for example, the velocity, the speed. What was the formula of speed? That was distance upon time. And what was the formula of velocity? That was displacement upon time. Yes or no?
Yes.
So, that is one concept. So, I think this was the last formula I discussed with you, if I'm not wrong.
Yes.
Right? Did I discuss the formulas?
No.
Okay. So, right now, the formulas is important. So, speed is equals to distance over time, and velocity is equals to displacement over time. So thereby velocity can be zero, positive as well as negative, but speed can always be positive, and speed shall always be either zero or positive. Okay, speed can never be negative because distance can never be negative. And I also told you that distance will always be greater than displacement. Yes or no?
Yes.
Greater than or equal to. So in the similar lines, speed shall be greater than or equals to velocity. But velocity is a vector quantity and speed shall be a scalar quantity. Yes or no?
Yes.
So that is the concept. Up till now, we have done this much. Now today, we are going to discuss a little bit more about the concept. The concept that we are going to learn today would be acceleration. Now, what is acceleration, Mark? What is acceleration? Acceleration means how much speed you are increasing, how much speed you are increasing per second. So if you drive something, if you drive a car, so let's suppose you leave from your home. So this is your path and this is your home, right? And you leave from your
Yes.
home. And when you leave from your home, what exactly happens, Mark? You are driving very, very slowly. You know, you're driving very slowly. But as the moment you reach on the main road, the main path, you start driving little fast, isn't it? You start driving
Yes.
really fast. Why are you driving fast? Because here, this cycle or whatever the vehicle was driving at, let's suppose, 10 kilometers per hour, very slow. But the moment you reach the highway, you start driving with the speed of, let's suppose, 70 kilometers per hour, very high speed, or 80 kilometers per hour. So, and this has happened. Let's suppose uh, let's suppose 1 hour, or it says, let's suppose 2 hours to reach from your house to the highway. Are you understanding that it is taking you how much time? In 2 hours' time, you reach from your house to the highway.
That the distance to the highway is 20 kilometers.
No, no, no. The distance must be some high value, but in 2 hours, because here you understand the speed is not constant. That's my point. A to B, the distance would have been 20 mark when the entire speed would be 10 kilometers per hour. You understand? But what
Yes.
is this person sitting on the bicycle doing? A. What is A doing? A is actually increasing its speed every second, actually. Every second the speed is being increased. So here, if you talk about this point at point C, the speed might be little different than the speed at point A. Because the person is speeding, the person is increasing the speed. If you reach at point D, the speed at D might be little more than what the speed was at point C. At E, if we are talking, the speed at point E would be even more than what was the speed at point D. So the speed at last P point would be the highest, which is 70 kilometers per hour. And thereafter, the person continues to move at 70 kilometers per hour, you know, for a long time. But from house to the highway, you understand? From house to the highway, because there might be certain streets right in front of that. So I hope you're understanding that, when we are doing this particular concept from A to highway, the speed is not constant, the speed is increasing. The velocity is increasing in this particular direction. I hope you're understanding, Mark. Tell me.
Yes.
So the speed is increasing. So I will say that, in 2 hours' time, how much has the speed increased? The speed has increased by 60 kilometers per hour, because his initial speed was how much? So, initial speed, Mark, initial speed, we denote by the letter U. U denotes the initial speed, and the final speed here shall be V. You understand? So, initial speed shall be U, and the final speed shall be V. You understand my point?
Yes.
So, how much has the speed increased? You tell me. The increase is of 60 kilometers per hour. The speed within 2 hours has increased by 60 kilometers per hour. Are you understanding my point?
Yes.
So that means what? If it is happening in 2 hours time, what does that mean? That in 2 hours time, the speed is 60 kilometers per hour. So in 1 hour's time, the speed shall be 60 over 2. That should be 30
30.
kilometers. So now understand, Mark, it is 60 kilometers per hour divided by 2 hours. So the number becomes 30. What does the unit become? It is kilometers per hour divided by hour. So it is going to become kilometers per hour into 1 by r, which becomes kilometers by hour square. Are you understanding my point? Did you understand
Yes.
the unit? So my unit shall become what? That ma'am, in 2 hours time, the speed has increased by 60 kilometers per hour. This much is the increase. So in 1 hour's time, how much is the speed increasing? Tell me. In 1 hour time, the speed is increasing by 60 over 2. So that shall be 30 kilometers per hour square. So this is the unit of acceleration. Are you understanding?
Yes.
Any doubts in this? Tell me.
No.
So that is the concept. That is the concept. Understood or not? Tell me.
Yes.
Any doubts in this? So
No.
if I say that, this is the speed. So 30 kilometers per hour every second, the person might be, increasing. So that means what? You tell me. That means what?
That means that
So when
it
when I
will
left
not
you,
be 30 kilometers per hour all the
exactly,
time.
exactly. So you started at 10 kilometers per hour from your home. Just after 1 hour, your speed has now become 40. Because after 1 hour, the speed is increased by 30. And then again, after another hour, the speed is increased by 30. So 40 plus 30 shall become 70. That's how the person's speed has increased. So the acceleration value, if I give you, like for example, if I give you the acceleration is 3 meters per second square. So I hope you're understanding this unit, how this unit has come up to be meters per second square mark. Tell me. How this speed has come up to be meters per second square? Tell me. Because what is that? Just tell me. Mm,
Because the
3 meters per
kilometer
second
came.
divided by seconds. Every second. Yeah. Did you understand?
Yes. 3
Are you sure?
meters per second.
Per second. Yeah. So it is meters divided by second divided by second. So meters divided by second, this you reciprocate. So this is why it becomes meters per second square. Understood or not?
Yes.
So now you tell me my answer. So for example, if I say, that this is the initial position, this is my school, and I start riding from my school at the speed of 5 meters per second. That's my starting speed. And u means initial speed. And now my acceleration is 2 meters per second square. So what will be my speed after? What will be my speed after 3 seconds? So my initial speed is already 5. And every,
Increase 2 meters every second.
yes,
So in 3 seconds, it would be 11 meters per second.
exactly. So what you have done? You have been given time. You are been given acceleration. So you multiply time with acceleration. Basically, this is what you're doing. That if in 1 second the increase in speed is 2 meters per second, so thereby in 3 seconds the speed would be 2 times 3. So the increase is in 6 meters per second. So my initial speed is 5. After 1 second, my speed becomes 7 because increase in 2. Then again at t equals to 2 second, my speed becomes 9. And at t equals to 3 second, my speed becomes 11. You understand my point? Because every second my speed is increasing by 2. So my formula here is what? What I'm trying to find out? I'm trying to find out V. I'm trying to find out final speed. Are you understanding? So my final speed would be what? My final speed would be U plus AT. U plus AT. So what is U? U is my initial speed 5. Acceleration shall be 2 and time shall be 3. Do you understand? So my answer comes out to be 5 plus 6 is going to be 11, isn't it? Because what am I doing? Every time in the initial speed, I'm adding up something. Do you understand how this formula came about, Mark?
Yes.
Are you sure? So u is going to be
Yes.
my initial speed. Are you understanding?
Yes.
And a is going to be my acceleration and t is going to be my time. So this is first equation of motion that you have to understand. This is your first equation of motion. Understood or not?
Yes.
Okay, very, very important equation. So there are two more equations of motion like that, but this is the very first equation, which helps you to calculate what? The final speed when the initial speed and acceleration and time is given to you. Understood or not?
Yes.
Right? Next question. Just see. Next question. Now there is another term called retardation. Retardation, or the term is also called as deceleration. The term is also called as deceleration. You understand?
Yes.
Now, what is deceleration? The decrease in speed
You
per second.
go down.
Exactly. The decrease in speed per second. 1 second.
And what? It's negative second squared.
Yes. So it is the decrease in speed per second. The decrease in speed per second is called retardation. Correct. So if initially my speed is, let us suppose, uh 10 meters per second. That's my initial speed. So how long would you think it will take me to reduce my speed to zero? My final speed should be zero. And my retardation is, so I will write down A only, but I will say minus 2 meters per second square. So minus means what? That minus is means reduction in the speed. The speed is getting reduced from whatever speed you had initially. The speed is actually getting reduced. Are you understanding my point?
Yes.
Okay, so that is the concept. That is the concept. So we will say A equals to minus 2 meters per second square. So you again apply the same formula. So by basic knowledge also, that if you start that ma'am at t equals to 0, my speed was 10 meters per second. So after 1 second, my speed will be reduced by 2. So what do you think my speed would be at t equals to 1 second mark? 8 meters per second. Again, after 1 second, my speed would be decreased. So my speed at t equals to 2 seconds would be 6 meters per second. I hope you're understanding what I'm trying to explain you. At t equals to 3 seconds mark, my speed would be 4 meters per second, because my speed is reducing by 2 every time. Are you understanding? My speed is reducing by 2 every time. At t equals to 4, my speed shall be 2 meters. And at t equals to 5, my speed shall become 0 meters per second. So, don't you think that I was trying to find out that at after how many seconds would my speed become 0?
Yes.
You understand the point?
Yes.
So, that is the concept. So, now if I apply you this u plus 80, 1 second.